I'm going to do this in two parts. I'm going to do the experiment here and take the data, and then I'm going to do a second video with the calculations. I need to do those on a different table. Okay, so this is the setup, and I'll just show you kind of a little home setup that I've got put together here. Just remember, if I was in the lab at school, everything would be a lot more professional looking. This is just a quick home setup. Okay, so we got on the diagram, we've got the ramp where the ball is going to be released, and then a flat part of the table, and then it's going to launch at some speed, velocity v, and then the ball is going to travel some distance and land. Okay, so the different variables we have here is d, so you need to measure that in meters. Let me do that real quick. So from the base of the table, from the base of the ramp to the edge of the table, and I set this up so it's right at 40 centimeters. So I'll just, I guess I'll just write this down right here, just right, okay? So now our calculations need to be done in meters. So 40 centimeters is 0.40 meters. Move the decimal point over 2 places. Okay. Delta Y, that's from the top of the table straight down to the floor. So we'll do that. Let's do that this way. I'll put that at 77 centimeters. So, sorry, write this down right here so I can remember it. So, same thing, 0.77 meters. Now those are not going to change throughout the experiment. Okay. Now what you want to do first, and I've kind of written out some simplified instructions here. So if you want to pause the video and copy these down, basically use these instead of what's written in the lab. I think it's much more straightforward here. Okay. So we're going to release the ball, and we're going to time how long it takes to travel this distance d from here to here on the table. Okay, I have a stopwatch to do that. Okay, because we need to calculate first this launch velocity v. And that's with this equation here. Okay, launch velocity v is the distance, which is not going to change from 0.40 meters for me. And then the time, which I'm going to time with the stopwatch in seconds. Okay, that's the first step. Now, I've actually already done that. Okay, because I can't release the ball, time it, and hold the phone all at the same time. So I've done that, okay, for the 10 centimeter launch height. So if you can see my ramp here, I've measured up from the bottom to 10 centimeters, roughly, and then 20, and then 30. Okay, so I'm actually going to do this experiment 3 different times for the 3 launch heights. Okay, so 3 different times at 10 centimeters. I've got 0.50, 0.68, 0.59. And remember, if you can't rig this thing together to do at home, you can actually use my data. So you'll want to be copying this down or pause the video. For 20 centimeters, my 3 times, 0.43, 0.47, and 0.50. And then for the 30 centimeter height, 0.31, 0.35, and 0.38. Of course, for the higher launch height, it's moving faster, so the time should be shorter. Okay, I'll go through all the calculations in the second part of the video. Okay, now the experiment is taking that V that you found and plugging it in to this equation here to predict the delta X. So to predict how far it's going to land from the edge of the table. Okay, and I've simplified it here. Okay, so it's square root of our delta Y times our V divided by 5. And I'll go through the calculations in the other video. Okay, so let me run through this. Okay, so I need to put that there. So I don't need the stopwatch for this part. But basically, I'm going to release the ball from 10 centimeters, let it run off, let it launch, and then try to estimate where it landed with the ruler. So this is a difficult part because I can't really see from here, but we'll try this. Okay, so here it goes. Okay, it's about right there. So 24 centimeters. So I'll copy that down. Okay, now I'm going to put that on this, and of course I need to record in meters, so 0.24 meters right there. And it's fine if you make your graphs look just like mine. Okay, that's what I want to see submitted. Okay, so let's do this way. Okay, trial 2. Okay, I was about at 20 centimeters, so 0.20 meters, and one more time. Okay, it's about at 21 centimeters, so 0.21. I'm going to go on to the second launch height, and I'll go back in the other video and do the calculations. So now I'm going to release from 20, and I'll just do these real quick. So here's 20, okay, about 31, trial 2, I'll call that one 35. And trial 3, 35 again. That second ruler is just there to help corral the ball. So, real quick, why we're doing this 3 times is because you can see they do come up different. And that's just little changes in the launch height. Will give you a different result. So, we're trying to get an average of these 3 runs. Okay, now for the 30 centimeter launch height. Okay, trial 1. Okay, call that 46. Okay, trial 2. 46 again. And trial 3. About 44. Okay, so that's all the data we need. So I'll stop here and then I'll do the calculations in the second video.